1 over 3 times what? The return. So the return will be what? 17%. 17%. So that is 0.17 minus, what is the expected return for B, stock B?
0.07.
0.07. 0.07. All squared plus plus 1 over 3 times the return for normal. Normal is how much? And for stock B, 7%. 7%. So that is 0.07 minus 0.07 all squared plus 1 over 3. What is the return for bad under stock B? Minus 3%. Minus 0.03 minus 0.07. I prefer to use decimals, but you can decide to leave them in percentage and work with them. Punch them as you see on the calculator with the percentage. But if you are not careful and you don't convert it to the decimal properly, then it means you are wrong. This is very risky because if it's 0.07 and you see 0.7, 0.7 is like 70%, and 0.07 is 7%. So you see, it's there are two different things altogether, right? So now, give me the answer for this one also.
Zero point
0.104.
041.
Yes.
0.104.
41.
Is it confirmed?
Yes.
Okay. So that's 10.41. Okay. So then, what is the next step? 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 Yes. What's the next step? Hey, the next step is silencing.
Compute the correlation coefficient.
Correlation coefficient. Okay. So what is the formula for the correlation coefficient? What's the formula for correlating coefficient?
The covariance. The covariance. It's giving the covariance of
A and B divided by standard deviation of A and B.
I didn't know. I just confirmed the B, and I realized I'm getting a different answer. I don't know if someone is the B, standard deviation of B.
That's correct.
Is it wrong with me? It's correct.
Yeah.
Okay. Is it that the two of you are making the same mistakes? A third person should
in the table. That was it. The return for stock B was it 0.03 or 0.06?
Which one? It's 0.03.
Yes, then it is wrong.
You've written 0.08.
My first answer was correct.
Which one?
What? They thought you wrote 8. That's why they gave you this answer.
And 3.
It is 0.3.
So the answer is 0.0816.
Exactly. That is what I'm having.
Oh, you gave.
I gave you wrong. I wrote 3. It is you that you didn't see you. Okay, so that's 0. What? 0 8 2 and that is 8.2%. And the next step is what? Let me try that. What's the next step? What's the next step? Hey, are they here or they cannot hear me?
Compute the portfolio standard.
Correlation standard deviation. It means you are not writing. It means you are not writing, right?
Oh no, sir.
Compute the correlation coefficient.
Yeah.
It's here. I see. Step 2. So step 3 is compute the what? Correlation coefficient. So what is the correlation coefficient formula? What is the formula for correlation coefficient?
Covariance. Covariance of. Deviation of A.
Deviation of B.
That's it then. Covariance is what? Covariance, right? Let me put this in brackets for revision purposes. So this is correlation coefficient. And that's equal to the covariance for A and B all over the standard deviation of A and the standard deviation of B. So this, let's get the covariance. Let's get what? The covariance, right? So let's try and make it in a table form and see. Okay, so let me see. Should I even bring the probabilities, all those stuff? Okay, so let me see. This is deviation of A. So the deviation of A is R minus the expected return of A. Deviation of B is R minus expected return of B. Deviation of A multiplying deviation of B. Probability multiplying deviation of A and the deviation of B. But what is the formula for the covariance, if I may ask? Did I give the formula for the covariance? Did I give the formula for covariance?
Yes.
That is right.
Yes.
Yes. It is the summation of the probability brackets open deviation A times the deviation.
Okay. So please, if you write deviation, express it like, say the formula R minus ER, because maybe everyone and where they learn their rates and return from. We are need to be also and rates and return. Someone might not even know what deviation is. Hey, what is deviation? What I know is R minus ERA. I don't know the deviation. What is deviation? As someone just asked. So when you say the deviation, you express it in, like, put it in bracket like what I've done, so that whoever is writing, oh, okay, so this is deviation. Oh, I see. What else? Yeah. So that is that. If you still don't want to use deviation, then you can just ignore the deviation and use R minus this, this times this times this, and then you multiply the probability, right? Without bringing the deviation. It is not relevant. You can decide to bring the deviation if you want, or you can decide to ignore it and just write your formula straightforward. Okay. So R minus R minus expected return minus expected return for what is the return minus expected return? You are doing for A. 7 minus what? I think in this table, I think it should be here, right? Isn't that this one?
Yes, sir.
Negative.
Okay. Negative 0.07 minus 0.11. What do you have?
Negative 0.18.
Negative 0.18. Then you do for this one too. Let's do the stock A before we come to stock B. So 0. Do you have?
For normal for stock A.
0.01.
0.01. It's positive, right? 0.01. And then the last one is what? Under stock A.
0.17.
0.17. Then we go to the B, stock B.
Thank you.
Stock B.
Zero point one.
0.1.
0.1. Okay. 0.1 is what? Is the last one. Is it the first one for B?
Zero. 0.
Is it the first one for B? 0.10.
0.1.
And this one, the second one is 0.
The second one is 0. What of the last one?
Negative 0.1.
Negative 0.1. Okay. So now let's find our deviation A times deviation B. Times multiply.
Negative 0.018.
Negative 0.01. And this is 0. And this is what?
0.
Yes. Negative
what?
0.017.
It's negative 0.
0.17.
0.17. 0.17. Then now use the probability. The probability is, let me even bring probability here now.
1/3.
Yeah, 1/3. So 1/3, 1/3 is 1/3 for both all of them. So multiply the probability times the deviation A multiply deviation B.
Negative 0.006.
Negative 0.00. Is it 6?
Yes, sir.
This is what? 0. 0. And then this is what?
Negative 0.0566.
Only 0.05.
66.
Is it negative?
It's like
Is that negative? I mean negative.
can be 5 Yes, 0. Negative 0.0057. Yes.
Alright, so what will be the total? The total is the covariance.
Negative 0.0117.
You see? The negative what?
Negative 0.011.
0.1.
0.01.
1.
$0.0117. All right, so this is the covariance. Now the correlation coefficient, we know that it is the covariance over the, so that will be negative 0.0117 all over. What is the standard deviation of A? What is the standard deviation of A?
Standard deviation of A.
0.1431. 0.1431 multiply standard deviation of B.
0.0826.
0.082. 0.08 what? 82. Now let me leave this one also. Okay, so what then is correlation coefficient?
Yeah, please. Negative 0.998.
So negative what?
Negative 0.998. Which one?
Negative 0.998.
Negative 0.998. So what is the interpretation of this? What is the interpretation of this negative blah blah blah?
Okay.
Yes, you can.
Don't worry.
Hey, our class, our school, dada. Yes, what is the interpretation of what we computed? Who can explain that? Okay, so it's negative, which means that the two assets are moving in the opposite direction, right? They are moving in what? The opposite direction. When we are having a negative relationship, means that they are moving in what? Opposite direction. Moving in opposite direction. So since they are moving in opposite direction, since they are moving, sorry.
Please, can you come again?
All right. So I'm saying that the curve, that is the correlation coefficient, covariance. The covariance or the correlation coefficient. Let me see. Okay, so the covariance is given as negative, right? So the covariance here means that negative 0.0117. It means that they are moving in what? The two stocks, the two assets are moving in the negative direction, right? They are moving in the opposite direction. Means that, and that is very good because it means that if one you invest in one and you are making there's a risk associated to that. It means the other will be very good to you. The other will be very good to you. That is the meaning of that. So, but with the correlation coefficient, whenever the answer is positive, it is not advisable to invest in it. Whenever the answer is positive, look at this. This that we've computed. So let me make everything simple. Whenever you compute the correlation coefficient, with the correlation coefficient, and you get a positive answer, it is not advisable to invest in such assets, right, or in those assets. But when it is negative, it is advisable to invest in that, right? So that's why I'm saying that positive relationship means that they move in the same direction. Means you are having an asset and then they are moving in the same direction. It means that whenever you are losing, whenever you lose two, you are going to lose all the two assets. But if they are moving in opposite direction, means that when one is decreasing, one is increasing. So when you lose one, you will definitely get the other one. But with the positive relationship, it means that when they are increasing, they increase together. When they are decreasing, they fall together, right? So it is very risky. Because I didn't lose, I will be losing all the investment. My investing sika can say, my losing but whenever they are in the opposite direction, when one increase, one will fall. So that one is good. So as an investor, you choose an investment that has a negative correlation coefficient. As an investor, you choose, let me even write it in the note. So note what I'm saying, so that when you are revising, when the answer into bracket correlation coefficient, let me even make RAP, so that is positive. It is not advisable to invest in advisable to invest in it. Invest in price positive relationship. Positive relationship means they move in the same direction. In the same or the direction. They move in the same direction, right? So they increase at the same time and decrease at the same time. So they increase at the same time and decrease at the same time. As an investor, I choose an investment. Choose an investment that has a negative correlation coefficient. Correlation coefficient. So in the event of bad situation, so that relation. So in the event of a bad situation, in the event of a bad situation, at least one of the investments would compensate you, and one of the investments will compensate. How do you spell the series card? Is it like this? Compensate you. Yeah, so I believe it makes sense, right?
Yes, sir.
Okay, so that's basically what I'm talking about. That's basically what I was talking about. Okay, so all right. So what is the next step? Final step? Is it a final step?
Now we have to calculate for the portfolio standard deviation.
Compute the correlation coefficient for each security. No. So it's together for the security. Sorry?
No, sir, it's not you.
Okay. So now the last one is what? Calculate the portfolio standard deviation. Right? Portfolio standard deviation. Even that is what the question wants, right? What is the requirement of the question? Calculate the portfolio risk and return. Yeah, so what's the formula of the portfolio standard deviation? Portfolio standard deviation. If you compute for the portfolio return, so we can compute the return, then we come to the standard deviation. Now let's compute the return. Compute the portfolio return and standard deviation. Portfolio return and standard deviation. Compute the portfolio return and standard deviation. So let's compute the return. So what is the portfolio return? What is the formula for the portfolio return? Yes, what's the formula for the return?
Weighted average times the return.
The weight times the what? Return. So what is the weight for stock A? What is the weight for stock A?
0.30.
0. What?
0.30.
SNA Limited invested 50% each of its investment in stock A and B. So what is the weight? 50%. So you think they just gave us the 50% for fun? Eh? They didn't give us for fun. We used it to compute the weight. Right? So the weight is 0.5 times the return of the stock A. What is the return for stock A? Expected return for stock A. What is expected?
0.11.
What is it? 0.11. 0.11 plus the weight times the expected return of B. What is the B?
0.07.
0.07. 0.07. So then what is our portfolio return? And what is our portfolio return?
Okay.
Omission. 0.9. 0.09.
0.109.
Yes, sir.
Okay. So 0.09, right? 0.09. Yeah, machine amount. I'm not the 100 years why I don't. Yeah. Then it may do the same design, like the beautiful for my ethnic differentiates the way that it's one way translate. And oh yeah, my choose to the American the amount. To show what's up. Yeah, I like the colors. Yeah.
Let me write my formula. I'm seeing the formula no one.
Yeah, just differentiate. It's something unique to differentiate them. Okay, so right. Okay. So yeah, so this is the portfolio return, right?
Please have a question.
Yeah. Yeah.
See, the 0.11 B is the expected return, not the return.
Yes, but note that the portfolio is talking about 2 or more investments, right?
Yeah, so you see, I think portfolio also have like portfolio return and portfolio expected return or something.
Okay, so to make it more clear, let me make this one expected return.
Yes.
Thank you very much.
And then I feel like the other one should be, because you see in the textbook we bought from the man, it was expected return of portfolio is equal to the weight times the expected return.
Yeah, so it's expected return. It's actually expected return. But if you so the you're talking about the first formula I wrote.
No, just this formula, this one.
Yeah, it's expected return. It's actually expected return. Why? Because the portfolio is talking about 2 or more returns, right?
Mm.
So the expected returns of each of them.
Okay.
All right. Thank you very much for the correction.
Mm.
Okay, so now that we are done with the return, now what is the next one? The standard deviation, right? So standard deviation, what's the formula for standard deviation too? Have you already computed the standard deviation? Standard deviation for the portfolio. Sorry, that's what I mean. What you computed was for the individual securities. I believe you are getting what you are doing, right? Are you getting what you are doing? This standard deviation is for each of the securities. We are talking about standard deviation for the portfolio, right? That is the requirement of the question. Look at the question. Calculate the portfolio return and risk. Risk is for the standard deviation. Standard deviation is used to measure the risk, and then the return is the RP. Now I'm going to calculate the risk. This is the risk. So what is the formula? What is the formula? Hey, what is the formula? Let me write standard deviation first. What is the general formula for the standard deviation? Hey, you don't mind me.
You said the general formula for standard deviation.
Yes.
Square root of variance.
Give me the variance. What is the formula for variance? Yeah, it's square root of variance. So the variance, what is the variance? What is the formula for the variance?
Return minus expected return squared times individual probability.
Okay.
Obiaka.
That's I see. Ayo. And you know, says I've the umpa Obibekamo ana. As I've seen Obibekamo ana one Obeka.
Anna Metro.
Aha, okay, in the money count trim. So the standard deviation of A is so that is 1. Probability is 1/3. What is the return? Return is what? I think we've done something like this already. Let me just do copy and paste. That will change the Hey, class, are you with me?
But we saw something similar like this.
Yeah, so are you with me?
Yes.
Yeah.
So should I continue?
We thought you do it just straightforward.
I mean, what I'm doing, should I continue?
Yes. No.
It means you're not with me. Hey.
Please, let's continue with the portfolio standard deviation.
And I are saying your own things. I see. You're talking about portfolio, right? Not the individual asset. So what's the portfolio formula? I gave the formula as the weight of A, standard deviation of A. You can bring the squared, or put them in brackets. Any way you do it. Which one do you think we should go by? This or that?
Any.
If any, then I continue. plus the weight of B, standard deviation of B squared. Then plus 2W. This formula is not difficult. 2WA, you can just learn it simple. 2WA, WB. And then correlation AB. And then standard deviation A, standard deviation B. Very easy, like. And then, so let's input the variables. So what are the values for them? So weight of A is how much?
0.5.
So 0.5 squared. And then standard deviation is how much?
0.143.
0.143. That one is squared. Plus weight of B, that's 0.5. And then standard deviation is how much?
0.082.
0.082. But if you have put this in brackets to be nicer. But anyway, let's continue. Plus 2WA. What is the W? Is 0.5 weight
Times 0.5.
Times 0.5. And then correlation is how much? Correlation coefficient.
Negative 0.998.
Let me continue here. Okay, negative 0.99 what?
98.
Is it 2 decimal place? Negative 0.98. Because here, then negative 0.98. Should I bring 8 like this?
It's 998.
998. What else? And then standard deviation of A. Standard deviation of A is 0.143 already here. And then standard deviation of B is what? 0.082. So give me the final answer. Risk and return is one of the easiest topics under financial management. Very, very simple.
0.03.
0.031 or 9.
1.
Is it confirmed? Le confirmant?
Yes, yes, it's like that.
Le confirmant. Okay. Don't tell me I didn't write something. Someone wants to ask a question. Yes, your question is warmly welcome.
Okay, please, I wanted to ask if there's an instance.
You wanted to ask, but you now change your mind, right?
No, but I want to ask, sorry, that
Okay.
is there any instance where covariance can replace correlation coefficient?
Is there any what?
Instance that covariance can replace correlation coefficient.
Exactly. She analysis no. Look at the analysis. In my this now. See then this AB is equal to cov AB all over. And if you want to make this the subject, it means that this is covariance is equal to what? This AB times what? Times A standard deviation of B. What I say? It means covariance AB is equal to this, right?
Yes.
Yes. And you know, sometimes we put, instead of writing, this is the same as covariance AB. And maybe after compute, you've already computed that, right? Computed cov AB. What did we get? Cov AB.
Negative something.
Yes. So this, let's multiply this and see whether you are getting the same answer. The whole of this. Multiply the whole of this. Yes.
I'm home, so I don't have calculator.
Hey! Financial reporting student, financial management student, what else? Quantitative method student. I don't know whether you're a BSc, but I'm just assuming you're a BSc as well. What else? Which other course involves calculation?
None.
None involves calculation.
No, I'm not a BSc.
You are not a BSc.
Yes.
I see. If you multiply, you're getting the same thing. If you multiply just this, aren't you getting the answer? Look at this. Let's multiply. Those two calculators confirm for us. Just this three. Hey, let me compute this one myself, because now I'm not too sure with your figures that you give me. Look at the one that you, please, someone should confirm this. Is it getting 0.031?
You say we should multiply the correlation times the standard deviation of A and B.
Exactly. Look at this correlation. It's the same as this times this times this. So we've already computed for the curve. That in the table, look at the table. We computed the curve. Yeah. Now I just want you to know that the curve AB is the same as the whole of this. The same as the whole of this. So just multiply and see whether you are getting the same thing. I feel I'm answering on the first.
So my question is that, you see, after getting the curve,
Yeah.
Can we just leave it at that and like use this as the correlation coefficient in the portfolio standard deviation?
Please come again.
I'm saying that, you see, you were like, I asked if there's an instance I replace the curve with the correlation coefficient.
Curve with the correlation coefficient. Just correlation coefficient is just this one. So you're asking, is there an instance where we replace this one, curve, with correlation coefficient?
Yes.
No, please. I've even never seen this before.
Okay.
Have you seen it somewhere?
I don't know if it was the standard deviation, but I saw they did 𝒂𝒂𝒓. I don't know if that was a standard deviation for variation or something.
It's not. It's rather cool multiplied by this standard deviation, and this is what is right. But what you are saying is that I'm not sure you are talking about this. Maybe a different thing.
Okay, sure.
Yeah. So you do your research and then confirm.
Okay. Thank you.
Welcome. It's not that now no one has confirmed this to me. Hey, these people. Financial management students, business finance students, University of Ghana business school students. Hey, accounting students. No one has been able to give me this. What are you getting for this? Are you in the end to us? I assume you should get the same thing. Okay, so now that is it. This answer, I don't know whether what you are giving me is correct, but that is what you are saying. And I think someone confirmed you are true. So
It's correct.
It's correct. Okay.
Yes.
So on that note, shall call it evening. Thank you very much for coming. This is where we end. This is where we end. As we meet and talk more before the exams. Also, look at certain areas.
Please, I want to ask a question, please.
You want to ask a question?
Yes.
Okay. Is it related to the topic?
Yes.
Okay.
Hey, so you see when you are using the historical record,
Yeah.
and so you were like, if there is no expected return, you do it return times maybe the average return. Is that what you were saying?
Yeah. If there is no probability, it means historical. So that one is average return.
Okay. You add the average and divide it
Yeah.
by the
You add
number.
10% plus 12% minus it maybe 3% divided by 3.
Okay.
Yeah. I mean it's 1, 2, 3. So you just add the 3 and divide by 3.
So it means the formulas are the same, but just that you just divide it by the number of samples minus 1 or something.
Yeah. So the probability is without n minus 1. That is, it is only this one that you have r minus, but that is average return, right? But if you see n minus 1 is for the historic.
Okay.
And this one is without n minus 1.
Okay, because there's probability.
Yeah, because there is probability.
Okay. Thank you.
You're welcome. Any other question? All right. If there is no question, thank you very much once again, and enjoy the rest of your evening. Bye.
Bye.
No, this is Isaac.
Yes.
Is someone speaking?
No.